We're able to take the gas from the air and condense it into a liquid. Everyone can see the liquid coming out of here. And it's very, very cold. It's air that's been chilled down. And it's so cold that it can make molecules move slower. The reason this balloon looks like this right now is because the molecules are moving pretty fast. And they're pushing against the inside. If we take those molecules and we slow them down, what do we think is going to happen to the balloon? Bigger or smaller?
Bigger, for sure.
Bigger?
Yeah.
Yeah? You're going to be here for a while, I think. It slows the molecules down, and they stop pushing on the inside of the balloon, and the balloon shrinks. And that's because it's so cold in here. Now, when the balloon starts to warm up, and it warms up pretty quick once you take it out of liquid nitrogen, you see it's going to expand again.
Oh my gosh.
And we can do that a couple times. So we use liquid nitrogen for a lot of different things. We can use it, just like we're slowing down the molecules in the balloon, we can use it to slow down the molecules in reactions. And when it's slower, it's easier for us to study. And we also use it, sometimes it pops because it gets stuck on itself, so don't be surprised. So it's so cold, and it's a liquid, which is small, and then it turns into a gas, which is sort of bigger, much like is happening with the balloon. And it turns out that we can actually do that with some milk and some eggs and some sugar and some chocolate, and we can make ice cream really, really fast because this is so cold and it expands so fast. So this is so this is what we do for the little kids. We light things on fire and we burn things and we mix drinks and then we make ice cream and we leave. And so they love it. It's a lot of fun. This is perfectly edible. And so hopefully I can ruin all your lunches with some chocolate ice cream today. So Lucas is going to help me pour. He's going to pour the liquid nitrogen into the milk mixture. And this is at room temperature, nothing special. And it's so cold that we can go from room temperature to ice cream in just a couple minutes. So, do you think I could ruin anyone's lunch today? It's pretty good ice cream.
Really good.
If you'd like to try it.
Spray solution on there, and the letters are going to become visible. Usually we say, hello, welcome. Today we're going to campaign a little bit.
We don't use this.
I'm going to vote yes on two.
By Harry Potter. It's a magic solution. I'll ruin the magic for you and tell you that it contains water and a chemical that is sensitive to pH changes, so it will change color. And what I have is things you find around the house. So I have a lemon, I have vinegar, I have baking soda, and I have ammonia. Okay? So all of these things you find in your life every day. And they're known, they can be classified as acids and bases. Okay, so these are acids, vinegar and lemon. And they're tart to the taste, right? That is an actual property of that particular type of compound. And then you have ammonia and baking soda, which obviously you don't want to taste either one of those, so we won't even discuss that. So what happens when I add something that's an acid to this solution? It instantly goes red. So, as I told you, it's not magic, but that's pretty magical. That definitely gives, not only myself an interest in science, but hopefully gives children an interest in science too. Now, a little bit more about acids and bases. So, they neutralize one another. They're kind of like mutually exclusive. So, in the middle we have water, which is a neutral pH. If you go one direction, you have acids. If you go the other direction, you have bases. And if you have acidic solution and you add a base, you're going to go through neutral and head towards basic solution. So, what happens when I add a base to this? Well, first of all, I'm going to neutralize the acid that's present. And then I'm going to turn the solution to a more basic pH, which turns this green. So, if you remember, it started out as kind of an ugly yellow-green. It went red, now it's green. Okay? So, if I add some vinegar, which again is an acid, I should go back the other direction, right? So this is like a teeter-totter. You can go back and forth pretty much all day long, all right? To an extent, but we won't get into those details. And I go back to red or orange. Okay, so it's a slightly different color, and that's because acids and bases have varying strengths. Okay, so some can be more acidic than others, some can be more basic than others. And so my final one is ammonia. This is my least favorite one because I always get this blast of ammonia in my face. But the cool part about ammonia is that this is a pretty strong solution, so it will make this solution pretty strongly basic, which will turn it purple, which is pretty.